Hello class, this is Mr. Burke and I want to explain our final project, which is reverse engineering. It's a culmination of everything you guys have learned up to this point, including all of your inventor stuff and then all the documentation regarding the design process. So what is engineering? Reverse engineering. Reverse engineering, also RE, is a process of taking something apart and analyzing its workings in detail, usually with the intentions of understanding its structure, function, and operation. Why do we use reverse engineering, or why is it done? Well, we need to document how things work and we need to analyze a process in order to see if we can do it better or a different way. Also, we discover processes and different ways that things interact, whether it's mechanical or electronical. And then we also do investigation based upon how things work and interact with each other. There's also product improvement. And like I said a million times before, guys, the world revolves around money. And if you're not continually updating your product or trying to make it better, then you're stagnant and your profit margin is going to be a lot less. So documentation, breaking it down, basically, if there's no documentation or something was like really old and then you wanted to make it new again, you need some sort of documentation. Reverse engineering is a great way to do that. Also for simple maintenance, or if there's inoperability of the product itself, you got to find out how it works on the inside. Also, it's used in different applications other than just mechanical, but then also in biomedical engineering or in genetics. You can see from the CAT scan here on the PowerPoint slide, or breaking down from the Human Genome Project. A lot of research and a lot of basic, advancements in medicines come through reverse engineering in the medical field. And also you can see through a bunch of pictures down there of high-tech military, top secret type things, commercial intelligence, like it says, curiosity. Those all need to be taken into consideration. Also, we need to investigate by analysis and testing. Document patent infringement, because something's entitled to something, whether it's their creativity or their intellectual property. We got to make sure that it stays theirs, and we don't infringe on anything, patent infringement or copyright infringement. And then also design and test failure, and that is something we get into a little bit more extensively once we get into principles of engineering next year's class. So here's another bullet list of things of why engineering is used. To improve or redesign a product to increase efficiency or reliability, improve manufacturing techniques, eliminate failure modes, reduce cost so we can increase profits. Also need to increase the ease of use, reduce negative environmental impacts, especially with pollution and the push towards green. Whether parts can be made out of recycled materials or not. Other tools that are used, micrometers, dial calipers, which we've used extensively. That's one with the digital display. It's a little bit more expensive than the ones we have. But also, biomedically, they have medical imaging, so you can see from the inside out. Interactive visualization using supercomputers, or Iowa State, like I've said before, guys, has a 3D monitor similar to the one that's in the bottom right-hand corner there. And then optical probes. And if you guys notice, the little probe on the end has a little red dot. That is actually a ruby, and those are really, really expensive, used for precise measurement and repeatability. So you make one prototype, and then make the tweaks on that, and as soon as it's exactly within tolerances, then you can build the molds off of that. There are 3 stages of reverse engineering: visual analysis, function analysis, and structural analysis. And we will get into all 3 of those, and all the documentation will be recorded in your notebooks as we progress through the whole unit. So first, function analysis. After a product has been selected, a non-destructive function analysis is performed. First, the product's purpose is identified. Next, observations are made to determine how the product functions. These observations are recorded in detail. And lastly, the system's inputs and outputs are listed. We will go over each of these through various activities in depth, so that way it gets covered more accurately and more thoroughly. So here's an example from an electric toothbrush here. The purpose of a toothbrush is to clean teeth and gums to prevent tooth and gum decay. Water and cleansing paste are used in conjunction with the brush. Now you guys can see there's a nice annotated sketch on the side. You guys will do the same, only be with your product. Okay, so complete with this annotated sketch is labeled, and then a hypothesis device to describe in detail the sequential operation or function of the device using the sketch as a reference. Then we get to the black box systems model. So what we basically do, we say we have to identify what goes into it, which is the inputs. Something happens, the product functions, and then there's an output. The black box is used to represent the product's internal components or processes which are deemed unknown at this point. Now, obviously, we know what a toothbrush does, but we don't know the inner workings of it without taking it apart. But we're not going to take it apart first because we have to hypothesize. Because maybe the problem isn't with the inside, maybe it's with the outside or the process itself. So as you can see here, it says hand motion, toothpaste, water, and energy goes into the toothbrush. Something happens inside the toothbrush once we flick the switch. Then what's made is sound, heat, waste, clean teeth and gums, hopefully. Okay. Now you guys might say, well, yeah, I know there's sound. What's the heat come from? Well, that's friction. And that is something you guys are going to include in all of yours because friction is a byproduct of any mechanical motion. That sums it all up. If you guys have any questions further, don't hesitate to ask. And thanks.